Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 22nd. Looking at significant wave heights for the North Pacific Ocean, we see nothing happening over the Eastern Pacific, but a gale, small but doing something, 26-foot seas approaching the dateline, aimed pretty well at Hawaii, good for probably some surf there, and otherwise, nothing else going on. Let's dive into the details. First off, we'll take a look at jet stream level winds. These winds up above 30,000 feet help support the formation of storms, and when those storms do form, help direct their track. Also notice, we are no longer using Adobe Flash on the weather models. Not the wave models, they're still on Flash, but the weather models have now all been converted over to our new JavaScript HTML5 viewer animated controls that will work on your iPad, iPhone, Mac computer, as well as Windows computers, Galaxy phones, and pretty much any mobile device. So we're pretty much good to go. Weather models, we've converted over. Everything on Stormsurf, weather model-wise, is mobile now, and we are in the process of working on the wave models and getting them set so they're mobile too. So what this means is you will not need to use the mobile site in the near future. You can use the site directly on your mobile device, anywhere, anytime, anywhere on the planet. You have a 4G connection, and you should be good to go. Anyway, so here we go. A little bit of a trough here. The jet stream pushing off of Japan, not particularly strong, 140 knot winds at best. A little bit of a trough here, supportive of gale development, and we saw on the previous chart, a bit of a gale is in fact in play there. But then the jet moves to the east, splits. The northern branch pushes up into Alaska. Southern branch takes a dive towards the equator, and that supports high pressure in between the two streams. So the only area of interest is right here towards the dateline. Let's put this into motion and see what happens. So we move forward, that trough works its way across the dateline, but also notice the jet starts splitting on Monday night, and that is not a good sign. That suggests less energy available across the North Pacific for gale formation. Anyway, a little pocket of winds here, 170 knot winds, almost looks semi-interesting, but as we roll this into motion, you see this split in the jet becomes very pronounced, a lot of energy pushing up into the Bering Sea. That gives no support for gale development here, and with another split over here, even less development on the U.S. West Coast. So basically, a very fragmented pattern sets up. And as we roll this out, we get into Thursday, and the split just gets more pronounced, and things just start falling apart. The jet becomes very fragmented. A little bit of a trough here trying to get organized, but it's just so pinched off, you're not going to get anything in that. And continuing on into the weekend, it just doesn't happen. The split just gets stronger and bigger, and all this does is support high pressure down at the surface. And we roll it on out to 180 hours, and there we are, basically a mess. So what this suggests is that because the jet is losing energy, that allows it to split. That's not an energetic state. If there were lots of energy, it'd be a single flow, one maybe good trough in the middle of it, and that's it. This all suggests that the active phase of the MJO is fading out. The MJO, in its active state, helps support or push winds or give more energy to the jet. That clearly isn't happening. The jet's falling apart. The suspicion is the MJO is falling apart as well, which means we're going into a down phase for storm production and therefore surf production as well. Continuing on with our inspection down at the surface level winds, surface level pressure. Here we go, our gale on the dateline. Little patch of 40 knot winds, but nothing particularly impressive. Roll this out, that gale continues on into about Monday and then just really kind of starts losing. Winds fall below 30 knots, no real propensity to support a swell period of 13 seconds or greater. Not particularly interesting, all wind swell production at best, and even that starts fading as we get into Tuesday. The gale's gone, high pressure off the U.S. West Coast, 1032 millibars, and nothing going on off Japan. Continue to roll this out, and as you see, nothing happening. A little bit of a gale finally come Thursday night, and into Friday we have, there we go, 40 knot winds, a little bit of activity. That aimed reasonably well at Hawaii, and that continues into Saturday, and then that gale starts lifting north, heading towards the Bering Sea, and that's pretty much the end of that. And by, there we go, into Monday, high pressure, one cell off of Japan, another in the Gulf of Alaska, Not a whole lot going on. A gale trying to organize here over Japan, but we suspect that's just bound to the north and will never see the light of day in the greater North Pacific Ocean. Next, let's take a look and see how winds on the surface are affecting the ocean surface. And we're actually going back in time to Friday. Here, this gale pushing off Japan, little area of 28-foot seas. That's aimed at Hawaii reasonably well on the 291 degree track. That's very westerly. For the most part, shadowed by Oahu. Kauai would be the main recipient of this energy. Anyway, roll this out. That system continued, sort of trying to organize, not particularly strong. And here we go. Oops, there we go, right there. Sunday, current time, relative to Hawaii. Energy still on the 291, 292 degree track. That's mainly, again, Kauai. Oahu, mostly shadowed. Needs to be about 296 or better to get in. 296 and a half, actually, for the North Shore. Anyway, and then a little bit of energy here, but that's all pushing south and of no interest. So let's put this into motion, see what happens. This gale basically peters out and dies by Monday morning. It's all over. And then we just see a lot of nothing, actually, just sort of background energy. A little bit of a gale here, trying to organize theoretically. Now we're into a week out, next weekend, only 18-foot seas. The better one is this one off Japan, if it actually forms. This is as of 18, this will be 18Z Friday, so you're talking 5+ days out relative to Hawaii. What's that, about the 306 degree track into Hawaii, and building 28-foot seas, and that's about it between the 305, 306, and 312 degree tracks for Hawaii, and that's by next Saturday. And then that starts heading north, and that's pretty much the end of it, and we're done. Given the prognosis for the jet stream, given the prognosis for surface level pressure, things are not looking particularly good. Next, let's take a look at the Southern Oscillation Index. Long-term indicators here. The difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO if they run negative for a decent amount of time, and positive numbers, the inactive phase of the MJO. Currently, we're sitting at positive 10.9, and it was even higher a couple days before. But we had come off a long run of negative numbers. It is not surprising that we're probably working our way towards the inactive phase of the MJO. It's about time. It's been negative for a good long while now. The 30-day running average making a startling upward trend to almost neutral, minus 0.84, and the 90-day running average on its way up at minus 5.80. Here's another way to view the 30-day average. Long term, last year, high numbers, La Nina almost conditions. Then the beginning, or actually 2013, in 2014, big dip of negative numbers. We thought a major El Nino was under development. Of course, things sort of rebounded. But then since July all the way through to now, we've been sitting long-running negative pulse. Now, all of a sudden, our big upward spike. We have no idea how high this is going to go, but we suspect probably not a whole lot higher. At least we're hoping not. This would then just suggest the return of the inactive phase of the MJO. Wouldn't be unusual, especially given the time of year. In fact, Tahiti, right here, here's our high pressure ridge over Tahiti. This is what's driving the SOI positive. And we could just roll this into motion here, and you can see the pressure is supposed to back off a little bit. In fact, a little bit of a gale here trying to get going in the southern hemisphere theoretically. But notice pressure it drops a little bit, but no low pressure of any sort forecast in this area. So we're not expecting a whole lot of change in the southern oscillation long term. Next, we look at wind anomalies on the equator. We're looking for westerly wind bursts, and in the West Pacific Ocean. Westerly wind bursts help support the formation of Kelvin waves. Kelvin waves, when they migrate towards the Galapagos Island on the equator, actually under the equator, then gurgle to the surface, create warm water on the ocean surface, and this is the hallmark of El Nino. Currently, we see no westerly anomalies. In fact, a bit of easterly anomalies. Here's the Philippines, here's the equator, here's Australia here. No real evidence of westerly anomalies as we work our way to the dateline. And then from the dateline east, still nothing, pretty much a neutral pattern. A week out, pretty much the same thing. Maybe a little hint of some westerly anomalies here at 160 east, but nothing particularly strong. And another little bit of gurgle of westerly anomalies here on the date line, not particularly strong. And then working from the date line to a point, where's Hawaii? It's right up in here somewhere. Hawaii, not a whole lot going on. Little bit and easterly anomalies, if anything, along the equator. So no real evidence of Kelvin wave generation, the active phase of the MJO. Not unexpected given all the other indicators that we're seeing. Here's another view. Actual wind along the equator. This is the East Pacific, the West Pacific. Actual winds, and ocean surface temperature. The anomalies is what we're really looking for. That's what the previous charts were. We're seeing no westerly anomalies, no easterly anomalies, just kind of a mixed general pattern. A little bit of warm water here, and we'll get into that in a minute, over the equator and the intersection of the date line. And that's about it. Now this is a little more interesting. We've shown this chart before. This is the whole world laid out on one chart over time. The West Pacific is roughly right here along this line. The East Pacific roughly along here. And these oranges, purples are westerly anomalies. And notice we had a westerly wind burst. It started actually around the 10th of January, I believe, and worked and basically was steady state, peaked out around the 5th of February, and continued up till just recently, and provided a good long dash of westerly anomalies over in the middle of the Kelvin wave generation area around, about 150 east, but now has petered out. The models suggest maybe a return more towards the date line, and we'll get into that in a minute. Looking at projections for the future, blues are easterly anomalies indicative of the inactive phase of the are the active phase of the MJO, indicative of westerly anomalies. This is the statistic model. This is easterly anomalies indicative of the inactive phase of the MJO. So one would kind of suspect maybe that this inactive phase is actually a little bit further over in this region and really taking its toll on the jet stream, but it could do it even from there. Anyway, the model suggests, this one, the statistic model, that the inactive phase of the MJO is supposed to slowly ease its way towards the date line over the next 15 days. The dynamic model is not as negative as that. It suggests that the active phase is supposed to hang, fade out, but not completely dissipate. So two models, two completely different projections, unknown what's really going to happen, but we would suspect a weak MJO signal regardless. That's what typically happens when you have both models suggesting a weak pattern, but in different directions. The net result is still no enhancement to the jet stream, not good support for storm development. And then this, the upper level, jet stream level wind model, the oranges and yellows suggest are areas not supportive of precipitation. The greens are supportive of precipitation. This suggests that the active phase of the MJO is gone, working its way into Central America, while the inactive phase works its way to the east the whole way through the month of March, finally gets about the 29th of March into Central America, and then a new active phase starts at that point in time. That would pretty much wipe out the month of March for any significant storm development. But this model, all the models at this point in time are kind of mixed, muddled, not showing anything coherent. So still, the net result is probably a very weak MJO signal through the month. And just to reiterate, the MJO in the active phase supports storm development in the North Pacific in winter months, and in the inactive phase does not support or even actively suppresses storm development in winter months, though doesn't preclude storms from forming. Anyway, so here we are. We're looking at surface level or ocean surface temperature anomalies, differences from normal, and we see light warm water in the Nino 3.4 area running from 120 west to 170 west. This is the main area that's looked at for monitoring the formation of El Nino. There were a lot of hopes that we would get into some kind of an El Nino this winter. We have not. We've gotten into what we call a Modoki El Nino. sort of El Nino, but not really. And it's really focused in the central Pacific. Normal El Nino is over here. So what that suggests is if you had a normal El Nino in this region, then the area of most storm development would be north of it, off the U.S. West Coast, in the Gulf of Alaska. But instead, we have a Modoki El Nino. The focus is on the dateline, and sure enough, this entire winter, all the storms that have formed have all come off Japan, bloomed on the dateline, and then pretty much dissipated. The Gulf of Alaska has been rather quiet. Precipitation in the U.S., along the U.S. West Coast, pretty light. The reality is, this is classic Modoki El Nino. So, just a little background information. Sea surface temperature anomalies during a classic El Nino. The warming is all off of Peru, the Galapagos Islands, and the East Pacific. During Modoki El Nino, or El Nino Modoki, the warming is less pronounced and focused here in the Central Pacific. Also notice, cooler than normal waters off the Philippines, cooler than water normals off Peru and the Galapagos, and this is almost exactly what we're seeing right now. Again, the current picture, cooler than waters here, cooler than normal waters here, cooler than water normals here. Here's your warming right in the middle. Looks kind of like this image right here. So the cause of Modoki El Nino, or classic El Nino, Walker circulation. During classic El Nino, the Walker circulation blows west to east the whole way across. That is, surface level winds or surface level anomalies blow west to east across the entire Pacific Ocean and causes warm water to build up off of Central America. In the El Nino Modoki, instead, you have sort of a split Walker circulation, with one blowing west to east, making it to about the dateline or so. The other circulation blowing east to west, both converging on the dateline. You get your precipitation and all the focus of your storm activity in the Central Pacific and nothing in the east, high and dry with an offshore flow, almost like a mini La Nina. And this is exactly what we're seeing both in California and in the Central Pacific in terms of storm production and precipitation. Next, we take a look at subsurface temperature anomalies. Here's the actual temperatures. Here is the anomalies. Notice 3, almost 4 degree pocket of warm water at depth. This is the West Pacific. This is the East Pacific. These are buoys that are part of the TAO array strung across the Pacific on the equator. Sensors at depth monitoring this area here. This is a Kelvin wave. It is created, as you remember, we had westerly anomalies just about the entire month of January and February blowing in the West Pacific. That took warm water there, pushed it to depth, created this pocket of warm water, again a Kelvin wave, and the expectation is this Kelvin wave will push east, work its way to the Galapagos, gurgle up on the surface, and warm the surface there, where trades will pick it, push it back towards the Central Pacific, and again help feed the warm water path that is the signature of this Modoki El Nino. This is a reasonably solid Kelvin wave, so just because we are in the inactive phase of the MJO cycle right now does not mean that El Nino is over, or that winter is even over for that matter. But for the most part, the cycle is continuing. This will help feed Modoki El Nino, but will not arrive until into the Galapagos until about May 1st. So, Kelvin wave is underway, in flight. This is a good sign. We're looking now towards the summer and fall of this year. Will this Kelvin wave help support the continuation of Modoki El Nino, or perhaps evolution into a full-blown El Nino? Unknown at this time. The other question is, are more Kelvin waves and westerly wind bursts on the way? That's what we're hoping for, and we kind of expect that's probably the case, because when you get in Modoki El Nino, you can go for 2, 3, 4 years in this sort of a pattern. Here's another view, sort of a modeled view. What do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one suggests certainly 4-degree anomalies, 4.5-degree anomalies. This is a good solid Kelvin wave, and again, will help warm and help fuel the jet stream at some point in the future. And finally, the forecast for the Nino 3.4 area. Again, that critical area between 120 west, 170 west, the hallmark of where El Nino is normally monitored. We see currently anomalies projected, or at least per this, averaging about 1 degree above normal, maybe 0.9. And the forecast is that over time, it's basically going to hold there and then perhaps slowly start rising to 1.5 degrees by October. This model then suggests that El Nino itself, not Modoki El Nino, but real El Nino, might develop by this fall. We find that probably not believable, but something to look forward to nonetheless. So for now, we have a gale on the dateline, generating some seas, probably targeting Hawaii more than anywhere. U.S. West Coast, kind of in a down swell pattern. MJO backing off. Probably not a whole lot of support for storm development for the next several weeks. We go into sort of a neutral pattern. The good news is there is a Kelvin wave in flight. There has been a long-running westerly wind burst. El Nino, of some flavor, is projected by the main model used by NOAA, the CFS version 2, and we'll see what actually happens. But for now, we're not in La Nina, which would definitely suppress storm development. We're in a break in the MJO cycle, maybe 3 or 4 weeks. We'll see what happens after that. Maybe we'll get an uptick for the spring portion of our winter season. But for now, things are slowing down a little bit. Get what you can. Get some waves. We'll do this again next week. Same time, same channel. See you then. Bye.